Hello and welcome to the second part of the tutorial about how to work with point clouds on Blender. So as you see, the point clouds has some that we can call hidden details. If you change a bit the point of view, you can see that, for example, here. Now, sorry. The navigation sometimes it's a bit here. Well, we have the line, and then we have this kind of separation of two surfaces, which might be grass or something else. And then we have in here some other irregular parts of the surface, and particularly this interesting was this line. Well, and this one, you have also some pattern on the floor. Well, I'm putting so much attention to this part because the final mesh will be destined to a simulation, to a car simulation, and they went all the way really through to make a laser scan, so because they really want the simulation to be appropriate. So the important part actually for the simulation will be the track, and the rest is just to make a video game. So this part from here, you see, from here basically it needs to be as close as possible to the original, and from this side on, the public should be just scenic scenario. So if you see, you have this detail which are the limitation of the car track, and we might find a way to preserve these, because yeah, we kind of need something precise. So basically, we don't need many details in the area of the seats. We need just some indication. Also for these poles, we need like placeholders. We know more or less the shape. We want to keep the shape, but we don't want to keep all the details. And we want to keep the shape of this one. So we have many possibilities. One is to separate the cloud between the central part, the one that actually should be really close to the original, where the cars go, and the exterior. Like this, we will treat them separately. We can import in Blender something not so reduced, some point clouds of the central part, not so decimated. You don't call it decimate here, but you call it subsample. Um, it means reduce the number of points to have a lighter file. I exported the PLY, which is the format that Blender used to handle the point clouds, of these 26 million points, and it's 1 gigabyte too. It's a lot, because in the file you will not have only these, which are 26 million points. It's already way over the possibility of many of the systems, like even 16 gigabyte of RAM, of really fast RAM of last generation. You will have some serious lag that will slow down and make your workflow impossible. So what you do is you choose from this menu by the side your point cloud, and you go here, subsampling. Here is the distance between the points. He will the software will pick a point every 3 centimeter, 10 centimeter, or they are meters, and they should be meters. So here we have more or less 20 centimeter, 5 meters. That means that if I pick a point every 220 meters, maybe for a whole planet would be good, but for this part we need something. I made different tries, and I saw that 0.16, okay, it's able to preserve a lot of details here in the area of the seats, as you can see. So you still see more or less the shape, the stairs. You see how the structure, because then you have to model. You have enough hooks to model on, and for here, for the part of the track, you still have, if you see a bit through, you have this line. Anyway, as I suggested you, it's better that you treat separately. You cut, for example, here and here, the guardrail, you cut the inner, and you subsample it, for example 0.30, which is the double, and this will give enough resolution to see the tiny details that I showed you before, that are the important part. Not all the point clouds are the same. Not all they need to be treated, and not all, for example, if it was just a building and what you need is more or less the shape, it's okay to subsample. If, for example, you need Notre Dame from a point cloud and you want to use it in as a background, or it's not really close into a video CGI, so that you can subsample more or less this rate, to be precise, or even less. If you need for a simulation, you need more density because you want to be more precise. So what we have here, it's our point cloud subsample. We can do before to export things like a Poisson recognition. It will rebuild the surface, but in order to do this, you have to have the normals. This particular point cloud went without the normals, so you have to make it calculate. And well, it's not really when it's automatically recognized, it makes a bit of a mess. So it's better that if you want really something top to work with, it will be a bit longer in on Blender, but you would make sure that you have top quality. So but you can do also some Raskin shape detection that gives you more or less the basic shape of the of everything. And this is the this is said that he wants not less than 500 point to recognize a shape. Let's put it like something like, I'm trying 50 to see. Now it's computing, it's doing. As you see, it created a simplified mesh showing some structure. And you have them all here. You can select them independently and export them as an FBX. If you select the whole, like this, you can export like DXF, which Blender is able to read. If you select only the planes inside, you can export as an FBX. You hold Control and you click on all the plane. You open. I know it's boring, I know it's long, but well, if you can export like FBX like this, clearly the less point you set for the shape recognition, for having a shape, that means that after it will find more tiny geometry like this. If now I delete all these, I reactivate my subsampled, voila, you need to reactivate it because every time it does a passage, it keeps the previous and it mutes it, it hides it. So let's do again the shape detection, but instead of 50 we put 200. The calculation will be faster, but as you see, You recognize less shape already. Delete, and let's see the plugins shape detection, and we do this time a super complex one. 15 point, recognize the shape. Voila, it crashes. See you in a moment.